So in our last update, we introduced the powerful 3D Mesh 2.0 and 3D Render Add-on 2.0 for Blender. They were kind of big hits because I've seen so many comments and discussions around it lately. I made another video on YouTube to compare the mesh results from the 3D Mesh 2.0 with photogrammetry method. So if you missed it, go check it out. It's actually pretty fun to watch. And guys, just merely 1 month after our major update, I'm here again to present to you our newest software update, KIRI Engine version 3.13. In the new 3.13, we drastically increased the fidelity of the 3D scan. Honestly speaking, when Chris showed me the early results, I wasn't even that impressed. I mean, yeah, it's much clearer than our older version, but what's the big deal, right? Until I did some comparison tests with other apps, and I was like, holy shit, I think KIRI might just have the best 3D quality now. Not only is the fidelity improved, but thanks to this new method, the file size of the Gaussian spots actually become way smaller. We're talking about 50% less file size compared to our previous version. And because of that, the 3D and KIRI scan now has way faster training and loading speed. And here's Chris to tell you more about this high-fidelity 3D Gaussian splatting.
To train 3D Gaussian splatting faster and significantly improve the fidelity, we use the new training method. In this method, it has two critical stages. First stage, we change the progressive densification to aggressive densification, which means we quickly generate a large amount of 3D Gaussians around the critical points and make them well distributed. Then, the second stage, we use a unique method to continuously simplify and optimize the 3D Gaussians by eliminating low contribution ones. Sounds great?
Alright, I know I'm not the only one that got a little bit confused, so let me show you what it really means in a simpler way. Imagine these MMMs are 3D Gaussians, and pretend that we need to use these 3D Gaussians to fill up this box on the paper to represent the shape of it. A traditional Gaussian splatting method is like this. We generate the 3D Gaussians in a certain order until the entire box is clearly filled up with them. Well, it works, but it's kind of slow. With our new method in 3.13, it's like this. We generate a huge amount of 3D Gaussians in a very short time. Then we use a special method. In this example, it's like we use a ruler to eliminate the relevant 3D Gaussians. See, it becomes way faster to fill up the box. It's kind of smart, right? And here, I actually need to give a big shout out to a recent research paper called Mini Splatting 2. The research and the people behind it have greatly inspired us in the making of this new update. And if you're interested in the paper, I've put a link to the work down below. But anyway, enough of the theory. Let's compare some of the 3D results with other apps. And guys, in the spirit of professionalism, I'm not going to tell you which other Gaussian splatting apps I've used. I'm just going to show you the 3D results from these apps and render them in a website called SuperSplat. This is one of the most representative examples. I believe Chris captured it at a coffee shop. All three results were generated using the same input video, but only one of them is from KIRI Engine. It's actually this one. Like, our fidelity is so good that you can almost read the letters and characters on the paper. Speaking of letters and characters, guys, check out this book scan. You can pretty much read the book from our 3D. Isn't that amazing? And not only is the fidelity improved, like I introduced earlier, when you update KIRI Engine to version 3.13, you notice a significant reduction in the 3D training time as well as the file size. Man, find me another team that can figure out a way to improve the 3D quality while still managing to reduce the file size. You guys are amazing. And by the way, some people were complaining about the scale issue in our 3D scan. Like when you export your mesh model to, for example, a 3D printer slicer, you find that the scale of our 3D scan is so off that sometimes you need to scale it 8,000% to make it right. Well, the reason was that for a 3D scanning algorithm that's completely based on photos and videos, it doesn't really know the real world size because the cameras don't really have true depth information. But in version 3.13, we've added a machine learning algorithm that can guess the object size based on its trained knowledge. I mean, the measurement won't be ruler precise, but it's definitely something that's good to have, especially if you don't want to scale your 3D model 8,000% every time. Alright, before I finish this video, just want to let you guys know if you want to try out the KIRI Engine Pro features such as the new high-fidelity 3D GS scan, you can actually grab a free one-day KIRI Engine Pro redemption code in our Twitter profile. We are doing it to promote our Twitter account because I feel our Twitter has been very underrated. So I'd be very much appreciated if you're going to grab the redemption code and maybe hit the follow button. But anyways, thank you guys for watching and I'll see you in the next video.